Hello and welcome to Los Alamos National Laboratory's Math and Science Academy. In this thread we'll be looking at the Common Core Standard for Grade 6, 6.NS.A.1, which is one of the most complex ideas students come across, and that is dividing fractions by fractions. We'll be working with a couple of word problems and also using visual fraction models. There are two threads for this standard. In the first one, we'll work with the idea of creating a story context and dividing 2/3 divided by 3/4 to give 8/9. That one also involves the words or the story context, how many 3/4 cup servings are in 2/3 cup of yogurt. In a previous thread, actually back in the 4th grade standard, we looked at how much chocolate will each person get if 3 people share 1/2 pound of chocolate equally. This idea would be a precursor to the thread that we're working on now. And then in a subsequent thread to this one, we will do how wide is a rectangular strip of land with length 3/4 and area 1/2, which is where the student is given a word problem and has to interpret it and do a division. The learning goals for this standard are to create a story context for a given mathematical task, visualizing and understanding dividing a fraction by another fraction, one of the most complex ideas students come across in their early math. The student needs to be able to fluently use multiple strategies. We'll talk about procedures as well as area models. And the student will communicate mathematical thinking with precision. So here's our problem. We're going to create a story context for 2/3 divided by 3/4 and use a visual fraction model to show the quotient. We'll use the same story context that was presented in the content standard. How many 3/4 cup servings are there in 2/3 cups of yogurt? When your students create these story contexts, it's important to be sure that the problem that they generate results in dividing 2/3 by 3/4 and not the other way around. In this problem, we can see that we have 2/3 cups of yogurt total, and we're dividing it into groups, each of which is 3/4 cups. So that's the language in this problem that specifies that we're going to divide 2/3 by 3/4 and not the other way around. There's another thread in this series that discusses the generation of story problems and how to be sure that and how to understand the direction of the division that comes up in the problem. In this case, though, we'll go on and use a double bar chart to explore this. We're going to begin by representing 1 cup of yogurt as this blue bar, and then break that into 3 equal parts, shading 2 of them to represent 2/3 of a cup. So this is 2/3 of a cup. That's the yogurt we have. We also need to represent the 3/4 cup, the size of a serving. And so here's another cup. We'll break it into 4 equal parts and shade 3 of them. And so we get this pink shaded region representing 3/4 of a cup. So our problem is now, how many times does this pink shaded region fit into the tan shaded region? And you'll notice immediately that the answer is less than 1. You will not get a full serving, 3/4 cup, out of only 2/3 cups of yogurt because there's less yogurt than a full serving. So we're going to end up with a fraction of a serving as our result. Specifically, what we need to know is what part of this pink does this tan represent? And so we look at this area right in here, which is the key idea. We have this excess amount here. Here is 1 full cup, 2/3 cup, and the important value is what's left over. So this is a piece that's left over, and we want to know of this whole, what was previously shaded pink, that whole part, what part is this? If we know what part this is, then we can figure out what the fraction is. So it all boils down to the size of this unit here. And as we'll see, it's similar to the issue of multiplication, finding a common unit in which to represent both the 2/3 cup and the 3/4 cup. So when we look at this, we see that this is approximately 1/3 of one of these quarters. And if we draw the other 2/3, then we see that we get 3 of these parts in 1/4 of the whole. And we can continue breaking up the rest of the quarters into parts, 3 parts, and we'll realize, we can see that we'll get 9 total units here if we break each of these quarters into 3 parts. So what is the size of that unit? Well, the size of that unit, if we break this additional quarter also into 3, we recognize that now what we've done is we've broken the whole into 12 equal parts, 3 for each of the quarters. So this is basically 1/12, and you'll recognize that as the common denominator of the 3 and the 4, the two fractions involved. And what that means is that we can also break this 2/3 cups into 12s. Now we just kind of guessed when we first picked this 3, but what we're seeing now is that breakdown, the unit size that we need, is actually based on the common denominator between the 3 and the 4. So let's break this other cup into 12ths, and what we'll see is that 2/3 cups is exactly 8 12ths, and 3/4 cups is exactly 9 12ths, which allows us then to recognize what our fraction is, what we're after, because what we're after is this piece here, the 8 parts out of the 9 parts that are represented by the 3/4 cup. So basically what we're saying is that we have 8/9 of a serving is going to fit in 2/3 of a cup. Again, the 3/4 cup is represented by 9 of these units, and the 2/3 is 8 of these units, and the units are equal. So we have 8/9 of a serving in 2/3 of a cup. You notice that the actual number 12 as 12ths doesn't really come up. It kind of disappears once you start looking at the fraction that's involved in the answer, but it's an important part underlying the meaning of this. In the procedure, once we get to looking at the procedure for this, you'll never see the unit 1/12. It all kind of disappears, but it is sitting there kind of underneath this problem, helping to define how to do it. So we end up with 8/9 of a serving in 2/3 of a cup. Here's our problem again. How many 3/4 cup servings are there in 2/3 cups of yogurt? We'll use an area model vaguely, but more important, we'll be talking about the idea of division as the inverse of multiplication to help us understand this. We'll begin by reviewing the concepts underlying division using an area model and whole numbers. So if you imagine a rectangular area of 15 square units, and you know, for example, that one of the side lengths is 3, then one can ask the question, what's the other side length? And we know that there's only one result, one value of x here that will work to give this picture consistency. So the question is, how do we find it? The way we can think of this is that 15 divided by 3 really means what value x can we multiply by 3 to get 15. So these two statements are equivalent. 15 divided by 3 equals x. If we think of this as the number we're looking for, then what has to be true is that 3 times x gives me 15. So this sets up the inverse relationship between division and multiplication here. So how do we find it? Well, we'll get to that in a second. But notice one way to remember this is to think of the traditional division symbol as two sides of a rectangle, with the dividend on the inside being the area, the divisor is one of the side lengths, and the quotient is the second side length. And that's really what we're doing when we're doing division here. So we know that 3 times some number is 15. So if we take a third of 15, we'll get 1 times that number. So conceptually what we're doing is we're saying, here's this number 3 times x, which is 15. If we take a third of that, we're going to have only 1 times x. So we take a third, and this is our bookkeeping over here on this side, to tell us that a third of 3 times x gives me x, and a third of 15 gives me 5. So the 3's here cancel in a way that we're used to when we're doing procedures. We can think of these two 3's canceling out, and we get x equals 5. So that's division of whole numbers. Let's see if we can translate those ideas into fractions. So here's our problem. We have 2/3 of a cup of yogurt. We'll represent that with this rectangle. And we want to see how many times does 3/4 go into 2/3, which is 2/3 divided by 3/4, and we'll get an answer somehow. Well, again, similarly to over here, what this means is that 2/3 divided by 3/4 means 3/4 times some number is going to have to give me 2/3. So now we're going to work the same way that we did over here and look at inverses. We've got 3/4 over here. 3/4 of a number is 2/3. So 1/3 of that is going to give us 1/4 of that number. So we're going to take 1/3 of each side, just like we did over here. Forget about the fact that we're working with quarters here for a moment. We're going to start just by taking 1/3 of our result, and then our bookkeeping is over here. And the 3's cancel again, like we did. 1/3 of 3 is 1. And so we just have 1/4 of x now. 1/4 of x is going to be this product here, which is 2/9. So now we've gotten rid of one of our issues here. We had a numerator of 3. We had 3 times x. But we also had a fourth of x, or 3/4 total. So we also need to get rid of this. And the way we'll do that is, if 1/4 of x is 2/9, then if we multiply that by 4, we'll get x. 4 times 1/4 of x is going to give me x. So I need to do that to the number, and I'll multiply by 4/1 is the way we multiply by whole numbers. And the 4's again will cancel. This 4 and that 4 and that 1 and that 1. And basically this is going to all go away, and we are left with what x is, which is 4 times 2 over 1 times 9, or 8/9. What we've seen in this is the whole idea underlying multiplying by the reciprocal. You'll notice that we started out with 2/3 divided by 3/4 was what we were trying to do. And mathematically what we did is we took 2/3 and multiplied by 1/3 and by 4, which overall is equivalent to multiplying by 4 over 3. So our 3 and our 4, when we did our division, what we ended up doing is multiplying the dividend, this is the dividend, by the reciprocal of the divisor. The reciprocal, the 3/4, became 4 over 3. We can check our work at the end and make sure that everything went right. 3/4 times 8/9. Our answer, we said 3/4 times 8/9 is supposed to give us 2/3. And so we can look at that and see if it does. 3 times 8 is 24. 4 times 9 is 36. And sure enough, 24 and 36 both have factors of 12. So we have 2 12s and 3 12s, or 2/3 for our result. So we can see that our quotient is correct. 8/9 works. So with that explanation, hopefully we're in a better position to understand the procedure that we're so used to using. Procedurally, 2/3 divided by 3/4 means 2/3 times the reciprocal of 3/4, or times 4/3, which gives you 8/9. This, of course, is the culmination of all this explanation here. There's a ditty that I've heard says, ours is not the reason why, just invert and multiply. Well, I disagree with that. I think ours is the reason to understand and reason why. Ours is the purpose to do that. And so hopefully now you better understand where this invert and multiply comes from. There are some other ways to remember this. Keep, change, flip is one. Keep the first the first fraction, change the sign from divide to multiply, and flip the second fraction. This is a common one. Kiss and flip is another way people talk about it. But regardless of how you remember the procedure for dividing fractions, it's really important to understand these concepts below and why it is that we're multiplying by the reciprocal. It's really because we're rewriting the division problem in terms of a multiplication problem that then needs to get undone. And that undoing is multiplying by a reciprocal. As I mentioned, a full understanding of 2/3 divided by 3/4, or dividing a fraction by a fraction, is quite complex. So it's important that you do some lead-up work towards this to understand some simpler cases. So I thought I'd show a couple of examples of lead-up tasks and some teacher work that was done for these. So here we have Sam is making banana bread. The recipe requires 2 3/4 cups of sugar. He only has a 1/4 measuring cup. How many 1/4 cups does he need? This example has simplified things by making sure that the units are all the same. We're working all with quarters. So the question, how many times does 1/4 go into 2 3/4, is really the math behind it. And we can represent 2 3/4 here. There's 2 wholes and then 3/4, and then simply count the number of quarters that are in there, and we get 11. So this is kind of a warm-up task that students should be very familiar with before they move on to the more complex ones. Here's another one that's a little bit more complex because it has a remainder. 7/8 of a pan of brownies were sold in 3/8 in packs. How many packs can they sell? What we've got here is a representation of eighths. So here's a whole, 8 parts, 1, 2, 3, 4, 5, 6, 7, 8. So 7/8 of the pan is this much here, to the left here. That's 7/8 of the pan. And so how many 3/8 packs? I'm not really sure what a 3/8 pack of brownies is, but we'll have to let that go. A 3/8 pack, here's a 3/8, here's another 3/8 in our 7, and then we have this 1/8 left over. But it's important to interpret that 1/8 for what it is. What it is 1 part out of 3/8, so it's 1/3 of a 3/8 pack. So now we're looking just at this one pack, and we see that what we have left over is 1/3 of a pack, because it's 1 part out of the 3. So we have 2 and 1/3 packs. So these are some examples of things that students should really understand through images and conceptually before moving on to the full-fledged one, which we'll do next. Here's some teacher work to describe and explore the question of 2/3 divided by 3/4. The teacher starts off with straightforward writing of the problem and almost can't help but to write that the result is going to be 2/3 times the reciprocal of 3/4. This is procedural thinking. They know it. That's where people go immediately. But the purpose here, of course, is to explain or show why that's true. So they start off with something akin to a double number line, very similar to the slide a couple slides ago, and represent 2/3 of a whole with this purple shading, and 3/4 of that same whole with this red shading. Now, because they've chosen to make the whole 6, 1, 2, 3, 4, 5, 6 of these squares, it makes it a little awkward to represent the 3/4. A quarter is 1.5 squares, and so they need 3 of those, and this line over here is not drawn really accurately. It really should be here, and because of that choice, it makes it a little awkward to see what part of this 3/4 fits in this 2/3. The teacher has the answer here, but it's not super clear to me how they came up with it. Something to do with deciphering this. 2/3 are 8 out of 3/4 or something, or 8 3/4. I'm not sure quite what that meant. But it's clear here with this full area model. What the teacher has done is drawn a rectangle that has 3 parts in one direction and 4 parts in another. What that does is it makes it very easy to shade 2/3 in this direction. Here's 2/3, and to put dots in 3/4 because we have quarters in the vertical direction. So we have 1, 2, 3. This is 3/4 of the rectangle. The setup here looks a lot like multiplication, and that can be confusing, but we're not doing the same thing at all. So that's partly why I don't like to use this area model, because it gets very confusing with multiplying. We're going to now interpret this very differently than what we did when we multiplied 2/3 times 3/4. That's not what's happening here. But we have represented 2/3, and we've represented 3/4. And what we're looking for is how many times does 3/4 go into 2/3? Well, the first thing to observe is that 3/4 is 9 of those squares, or 9 of those 12ths. These are 12ths. It's that common denominator. So 9 of those represents 3/4. Well, how many times does that 9, that set of 9, go into 2/3, which is only 8 of those 12ths? So 2/3 is 8 of those 12ths, whereas 3/4 is 9 of them. How many times does 9 go into 8? Well, that's 8/9. 8/9 is the number of times that the 9 goes into 8, not quite a whole. And so they've come up with the answer visually and written the math sentence here: 2/3 is 8/9 of 3/4. You'll notice right here a little bit of the confusion. 3/4 of 2/3, that's multiplication. So we really need to be clear, if we're going to use this kind of area model, that we're not multiplying 2/3 times 3/4. We're not looking for the intersection of these shaded regions, which is what we did in the previous one. What we're looking for is how many 3/4 are in 2/3. That's division. So we're counting and interpreting this area model very differently. And then down here you see their final check: 8/9 times 3/4 is 2/3. Presumably they did that in their head to confirm that their answer was right. So this illustration from the teacher has a lot of really good meat in it and really shows different thinking and the use of this area model. So I hope that through looking at these various slides, you've come to a deeper understanding of why that procedure works. The procedure of dividing by a fraction means multiplying by the reciprocal of that fraction. That's the procedure that we all have come away with, but hopefully now you understand more deeply why that's the case.